The last section that I'm going to teach you guys and go over with you is on triple integral. Here is the actual definition of our triple integral. So it's defined as the limit as the norm of the partition approaches 0 of the sum of f of x sub I, y sub y, z sub I, delta v sub I. So it's still a Riemann sum. It's small little volume pieces, little rectangular prisms, if you will, summed up together. So taking a look at this problem, example 1, we're going to integrate with respect to z first. So we need to write out the two outer integrals again and integrate the inside with respect to z, which should be easy. It'll be z sine y squared from 1 to 3, and then dx dy. You do have to write out everything until you are done integrating that piece, so you can't get by without writing all this stuff out. It does need to be written. So plugging in the 3 and then plugging in the 1, so you're going to have 2 sine y squared dx dy. Now integrating with respect to x, here again it's kind of nice because there is no x there, so we'll have 2x times sine y squared from 0 to y dy, and plugging in our y in 0 gives us 2y sine y squared dy. Now we actually can just use a u substitution, so when I integrate, all I get is a negative cosine y squared from 0 to radical pi over 2, and when plugging that in, we get negative cosine pi over 2 minus a negative, so cosine of 0, which is going to be just 1, because cosine pi over 2 is 0. The integral from 0 to 2, the integral from 0 to x, the integral from 0 to x plus y of e to the x times y plus 2z dz dy dx. And next year, when you guys work on this, you will be changing up the order of integration. So let's see, integrating with respect to z. So that's going to give me e to the x times yz plus z squared from 0 to x plus y dy dx. So plugging in for z, we're going to have now y times x plus y, so I'm going to multiply that out. And then now plugging this in, I'm going to multiply out my x plus y as well. So I'm going to have x squared plus 2xy plus y squared dy dx. Now I will combine a couple of these things together. So I'm going to combine my xy's and my y squareds before integrating. So I'll have x squared plus 3xy plus 2y squared dy dx. So now that I integrate with respect to y, I'm going to have x squared y plus 3 halves xy squared plus 2/3 y cubed from 0 to x. Now plugging in for y, it's going to give me x cubed plus 3 halves x cubed plus 2/3 x cubed. Then when you plug in the 0, we just get 0. So I can add all of these x cubed terms up, and that's actually going to give me 19 over 6 x cubed. This is going to require an integration by parts, and I'm going to use tabular because of the x cubed. So if you guys remember how tabular integration works, we're going to put x cubed, then e to the x. I'll get 3x squared, 6x, 6, and a 0. And I'm going to have e to the x repeatedly. So this is going to be plus, minus, plus, minus. That's going to leave me with my 19 over 6 e to the x times x cubed minus 3x squared plus 6x minus 6, evaluated from 0 to 2. So 19 over 6 times e squared times 8 minus 12 plus 12 minus 6. And then plugging in the 0 gives me minus 1 times, all of these are 0 except for the last one, negative 6. Be careful and don't forget that last term. And this is going to equal to 19 over 3 e squared plus 19.